Now, as we get started, I realize we're here to talk about digitization, and I started to understand just how many digital devices that I have to manipulate during this talk, because I've got my headset and my microphone and my clicker and my phone. It's kind of humorous to me that this is how we begin. So first, let me formally welcome you to our university. It's a great pleasure and honor to have you here. This is an important project, and there are a lot of very important counterparts and colleagues working together to make this happen. We've received a tremendous amount of support from our respective institutions. I know that we're all under a great deal of pressure to deliver progress with digitization. My hope is that working together we can do so. We can get further together. Now, you may know quite well this gentleman. He has been an inspirational force in the creation of these initiatives. He's the main mover and shaker of the Digital Kazakhstan project, and it was at his request that we organized this idea of a center of competencies. Now, I don't actually have a good title for this center of competencies, because you might ask, what kinds of competencies? And maybe I'm just going to say all of them, because we're talking about artificial intelligence, about big data, about data science. There are so many application areas. I'll show you these in the course of our presentation today. So I'll mention first and foremost, the idea of the center and of our collaboration is to achieve the potential benefits of digitization. And there are many. I don't need to convince you of the potential. It's enormous. But it's a very difficult process to achieve these benefits. And it's not through one or two developments that we attain the progress. It's many of them operating simultaneously to achieve this goal. We've been asked to serve as the seat of this center and to serve, in effect, as a coordinating capacity. But we do this working very closely with our colleagues at Zerde in particular, who have been relentless in their efforts. And our purpose is to support education and trainings for the top level of the country. Now, I need to emphasize something here. We talk sometimes about awareness and education and mastery of a domain of subjects. And we have to distinguish our terms as we go, because there are different outcomes and different achievements possible with each level. We'll be careful through this seminar series to scope our work, to describe our objectives, to make sure that we define our constituents so that we have achievable outcomes. Now, you might recognize this guy. Mr. Katsu has been an inspiration to us. He has very high ambitions. He shares these with the Deputy Prime Minister. Both of them have high expectations for our common activities. One point from Mr. Katsu that I want to emphasize today is that he has a very strong belief, along with our provost, Adesida, that we should align the work of our university to a large extent, the research and the development work of our university with the development ambitions and objectives of the country. And as much as is possible, working together, again, we can achieve more. Now, you might recognize this guy. I have the great pleasure to introduce Provost Adesida. He has been a very strong supporter from the beginning of this initiative, and he very kindly joined us today in the midst of a quite busy schedule to demonstrate the ongoing support. Now, he comes from a fairly famous institution with a very strong background that I'm going to emphasize now about breaking boundaries and promoting interdisciplinary work, because this is quite important for us. The breakthroughs, the successes that we have often come by working together. It's not just one subject or one field or one expert or one department or one ministry that can achieve this. So this is a very strong statement from our provost. This is the dean of our School of Science. Now, of course, our university has many schools, and many of them are contributing to these data science initiatives. We have people, I have a long list of the schools and the departments, and in fact, a number of those researchers and faculty members have joined us here today. But our dean emphasizes something that's relevant and a little bit important for the digitization efforts. Our programs are based on the American system, based on the best practice models. And the instruction that we give our students follows that model. It's a point of distinction. It's something that makes us perhaps different from some of the other Kazakh universities, that our courses would be recognizable really around the world, and that our programs of study are based on the curricular guidance that come from the professional societies of each subject. So mathematics, chemistry, physics, computer science, and so on. I'm describing this for one school, but it's true of all of our schools at the university, that we have this alignment with the highest standards of the professional societies and of our counterparts in other countries. For example, some of you may well know this, for others perhaps not. Our university was founded with partners from 6 of the top 30 universities in the world. It was a conscious decision so that we could try to move further, faster, and learn from the vast experience of some of the world's top universities. In fact, this is one of the reasons that we recruited Provost Adesida from the University of Illinois, very famous for its science and technology. So I mentioned only 3 of our schools in this example, but they're relevant for our discussion. Our School of Science was partnered with Carnegie Mellon University, famous for robotics, computer science, and technology. Our School of Humanities with the University of Wisconsin, again famous, one of the most progressive institutions in the United States. And the engineering school originally partnered with University College London. Now these were our founding partners. Our curricula and our courses were based on the guidelines that were influenced very strongly by these experts. Now, I'm going to say a little bit more about our local capacity, because this whole initiative is about capacity development, but not just in the university, but really for the country. But in order for us to understand our mutual needs and mutual capabilities, it would be helpful to understand those existing resources. So I'll describe some of these today in the course of this seminar, but I want to emphasize that this is a university-wide initiative. Although I myself, I'll actually introduce myself in a moment, come from the School of Science, I'm really speaking on behalf of the entire university in your presence today. Now, the experts that we have that are relevant for these data science initiatives come from the School of Science, the School of Engineering, the Graduate School of Business, and our National Laboratory. You'll see some examples in our slides, and you'll see seminars in the future from experts across this range. Now, I mentioned the School of Science, that we have these departments, and in particular, I emphasize the robotics because it's unusual for a School of Science to have an undergraduate program in robotics. We have this program because of our history with Carnegie Mellon, which was famous for computer science and robotics. Now, this gives us a peculiar advantage because a great deal of artificial intelligence, intelligent systems, and the like comes from the synergy between these two fields. So we have a very substantial collection of researchers who are active in their own fields and working together across the disciplinary lines. And I emphasize that because I include the other departments because they've all become computational. In fact, the new chair of our Department of Biology, who has also joined us today, is computational. He's an expert, a world expert in bioinformatics. And you might wonder why bioinformatics is relevant to our digitization objectives. It's because the tools and the techniques, the kind of data that's collected, that's organized, that's analyzed, and the kinds of outcomes from this analysis, these are migratable skills. These are techniques that work beyond biology. And the impact is there if we think about digitization, because after all, we're looking at services throughout the economy, throughout society, including education and healthcare. So this is quite relevant for us. Now, I mentioned this slide to give you an example of the kinds of courses that we run here, the kind of education that our students are getting. Every semester, every year, there are 30 students who would be trained in every one of these subject areas. Every one of these corresponds to an actual semester-long course, sometimes more than one. Those may not seem like large numbers, but that's a lot of courses times 30 students every time, every semester, every year, ongoing. And we're expanding. Just in the time that I've been at the university, we've doubled the number of students in our school. And we've been asked to double again. And the areas of greatest growth are the areas most closely connected to this digitization initiative. So I find that very reassuring. And I'll tell you why in just a moment. I should also tell you, these pictures are not so much there for you, but for me, because I'm an older guy now and I get forgetful. So these are reminders to myself to tell you stories along the way. Okay, now I'll introduce myself. Michael Lewis, I'm in our School of Science and Technology. I serve as the Vice Dean for Academic Affairs, but I have some history that's relevant. And so I'll bore you with that history. Previously, I was the chair of computer science. But before I came to Kazakhstan, I was in the Middle East. I was in Qatar. I was working for Carnegie Mellon. I was a cybersecurity specialist, and I was the deputy director of the National Cybersecurity Program. So that was the connection that led me to come to Kazakhstan. So I have a background in computer science and cybersecurity. I was at Carnegie Mellon for some years. It was a great privilege to have that experience. And prior to that, I was at New York University at a fairly well-known institute for computer science and mathematics. But maybe more relevant is that for many years, while I was in New York, I worked as an advisor and consultant to a number of United Nations agencies on issues of technology as part of national development. So the introduction of internet infrastructure, the introduction of technology into education, some of the issues involved in reaching out to the regions from the highly populated urban centers, all of these things. I worked on these projects for the United Nations Development Program, for the International Telecommunications Union, the International Center for Trade, and the US Agency for International Development. So it's kind of interesting that what we're doing now parallels very closely to the kind of work that I had been doing before in New York. Now it brings us really more to the business at hand. So if this is the background, of what we can do at NU, let's talk a little bit more about how we're trying to synchronize with the national ambitions for digital Kazakhstan. Now, I have to tell you immediately, I'm not an expert on this program. I didn't write the program. I wasn't involved in the dialogue with all of you for its creation and its design and its execution. But we believe in the program, we think it has great potential, and we've been asked to contribute, and we're happily trying to do so. And so part of what we want from this project, this series of seminars, is to help with that alignment so that we can achieve some of these high-level goals. And they are high-level. When we talk about the Digital Silk Road, there's a lot of discussion about infrastructure. And this is a very big challenge for Kazakhstan because it's, you might know, a big country. So the challenges of distance are non-trivial. We need to make sure that the people in the society have the skills, have the awareness, the education, the mastery, in order to be participants, to be developers, to be users of these systems. Again, this is quite a leap forward and difficult to do in one go. I'll talk about that in a moment. The transformation happens ideally because what we're doing is more efficient. It helps us deliver services better, more cheaply. It allows us to reach out to people and provide these services in a way that maybe we couldn't even consider before. The future of some disciplines will be completely transformed. I have a note at the bottom. Think just about something like architecture. 20 years ago, there was an architect and maybe 50 or 100 draftsmen who just drew the pictures. Do you think there are any people left drawing the pictures anymore? This is all done by computer. And an entire industry was transformed by design technology. Or think about media, newspapers. Even the New York Times has said that within 10 years they expect to end the printing of the newspaper, that it's becoming something of a novelty and something of an economic liability to print the newspaper. So we know that we've gone through major transformations and there's a great deal more to come. Now the digital government, this is very close to you because the way the work is done, the way the rules are developed, the way that they are displayed and presented to the people, the way that the people comply with the rules, with the guidelines, the way that we deliver many kinds of services will change. And we'll talk about some of the examples that you're already conducting now as pilot projects. And then really the innovation ecosystem idea is to create an environment which allows these things to emerge. And we'll talk about what those factors might be as we go along. Now, to these ends, we have prepared a series of seminars. We'll conduct these once a week, and these will be on fairly specific technical topics. I think you've all received the full set of these topics. These were chosen based on feedback from Zerday's consultations with you and with the community at large. These are the topics that people have requested. And fortunately, these are areas where our university has capacity, where we have experts in, for example, big data and data mining. We're joined today by Dr. Mark Sterling, who's a specialist in data mining. And this, you'll see a slide towards the end, is kind of a big deal. And I'll come back to that in a moment. We have also a topic in machine learning and artificial intelligence. And Dr. Varol, who's over in his lab right now, will lead this session. I have to warn you, today it's not very technical. It's conceptual. But when these experts are talking to you about their areas of expertise, it will be more detailed. Each of these lectures will be designed with some history, some context, some current works, how do these things happen, and then a little bit of the future. Where is it going? And how could that idea integrate well with the Digital Kazakhstan initiatives? So some of them will become technical. Some of them will be mathematical. For example, machine learning is very mathematical. Luckily, we won't quiz you on the math. You would just understand that there's an approach, there's a technique, and whether you believe that one or not, someone has demonstrated that it's true, and then we can see the results. Because for you guys, what's important, and this I need to emphasize, you don't need to know how these things are working. You need to know what they can do. So the projects that you're managing and the people that you're overseeing, you understand what's possible. What problems are solvable now, what kinds of things we can do, and which things are maybe non-topical or outside of consideration. So it helps us with the scoping of the problems. There are certain things that we can do with big data that are easy now. And there are some things we can't do yet. There are certain things that we can do with machine learning. And there are some things that we can't do yet. So understanding those boundaries will be a big part of our discussion. So there will be a balance between the conceptual details and the technical details. And then later, because these folks from Zerde are very aggressive and very pushy, they want us to do more technical training. They want us to do, with your staff members, micro courses where they pick up practical skills, how to work with these ideas, with your data, with your problems to get concrete results. So this is an important priority for us. So you see the full list: image processing, multimedia databases. Dr. Adnan is here as well, joining us recently from Turkey, the Middle East Technical College. The bioinformatics, which for me is super fascinating. I'll come back to this. Sensor networks, there's so much data. You'll see, when I tell these stories, you'll see. The speech recognition, this came from you guys. It turns out that there's a lot of interest in chatbots, speech recognition, natural language processing. We have a group in our national lab that's done some exceptional work here. I think they may be the most accomplished in this area in the region. So we'd like to make those resources available to the groups that might need to use those resources. And then towards the end, we'll talk a little bit about cybersecurity. I have a short presentation today on blockchain, but this is a high priority, we've come to understand. So I've moved that discussion up ever so slightly. This is our working schedule, subject to small changes in the sequencing of the topics. But also, based on feedback from you, we may adjust how much emphasis we put on one topic or another. Or maybe there's something that we're missing that you need. You can ask us about this. We will send you a survey, and you can come back to us with your interests, with your priorities, so that we can, again, align more closely together our common interests. Now, I have to apologize to you. I lecture students for a living. I do it every day. But here I am talking to you. I'm lecturing you about things that probably you already know a lot about. 80% of what I'm talking about, you know. I don't need to convince you. So then what's our purpose? I thought about this. One is, well, no one knows all of it. So it's useful for the review and to fill in some of the missing pieces, that extra 20%. Some of it will cover topics that you haven't thought about yet, you haven't had the time. But sitting through that lecture will give you a nice overview, a fairly clear conceptual understanding of why you might or might not want to use that technology. Also, our experts know this material well, and they know where are the authoritative sources, who has the best materials, who has the best approach. So we can provide, perhaps, some references and some links to this material. In addition, just networking. You're going to meet people here and who join our groups who have interests that are similar to yours. You might also get a few examples that you could use and reuse to help explain these ideas to your people. And we would like to connect the CDOs, the researchers, and our students. We have a lot of students. It's one of the main things we do here. We have more than 4,000 now, growing to 8,000, and we train a lot of them in the core technologies that we are using, that we're talking about. So it would be useful for us to connect our researchers and our students with these projects so that in the summers, during the term, internships, future employment, perhaps thesis work, there are a lot of opportunities for our students to work with your projects. This could be done in a selective and targeted way with potentially some good results. So this is why we're conducting this series, to help round out the information. Now, please bear with me for just a few minutes. I'll go a little bit further and then we'll pause for our coffee break.
Sorry, can you go a few slides?
How many slides?
We schedule.
Okay.
We we are planning to have like each week by Sunday
On Saturdays,
or Saturday, the same time.
the same time every week, 1 o'clock on Saturday, this meeting, in this room with the same people. Luckily, it won't be me talking every week. We have all these other experts who will be presenting.
For 2 hours.
Yes, a little bit less. A total of talking of 90 minutes. Okay? So, within all of these subject areas, certain words come up over and over again. So I want to take a moment to define these words, to explain a little bit about the, to untangle them slightly. So we talk about big data, data science, AI, and intelligent systems. What's big data? This is the formal definition. You can find this online. It's everywhere. Wikipedia. And it's all about basically collecting data, but trying to work with it to perform analytics that have been difficult before because of the sheer volume. So we collect it, but we're overwhelmed, right? So we have to worry about how to capture this, store it, analyze it, search it, share it, and so on. This is quite a wide range of tasks. But if we're able to do this, then we perhaps have some achievements. Now, maybe less formally, everything we do now generates information, generates raw data. We have sensors. Everything we do with transactions generates more data. We have data and metadata, data about data. And we're able to perhaps gain insight once we understand this volume of data. So this is the phrasing of big data. Next week, we have an entire presentation on the implications of this, so I won't spend too much time on it, other than to say that big data and data science are related. Data science is the approach, the field, the methods, the processes, the systems where we extract knowledge. So we're not talking about data, just data. We've gone from data to information to knowledge. So this becomes something with which we can work. This becomes, in some form, intelligence. In various, and the information can be either structured or unstructured. Databases are free-form text. Lots of examples. Data science is becoming the catch-all term for almost all of the works that we're doing within digitization. And again, working with Zerde, working with the government, we're talking about organizing a new program in data science for working professionals. So the people in your teams can get the specific skill sets they need to be ready for the jobs that you have now. Now, this visual is only here to say that there's a lot of components to data science. Lots and lots of stuff that becomes immediately relevant. We'll see more examples. Now, AI, without a formal definition, it's a machine that interacts with the environment to acquire information and learn. Okay? I've been working in artificial intelligence for more than 30 years. When I started, we had very limited ambitions. We were very happy if we could recognize in a picture the corner of a table, for example. This was kind of a challenge for us. Our textbooks spent a lot of time looking at trying to figure out what were shapes. We were also very motivated to teach a computer how to, say, play checkers. This was considered a big challenge when I was starting. And then later, okay, chess. Well, you now know recently that an artificially intelligent chess program taught itself how to play chess without knowing how to play chess, and then became one of the best in the world, beating all the other computer chess games within a weekend. Just a couple of days of effort, and it was done. So then they moved from chess to the game Go. And of course now we have an artificially intelligent Go playing machine that's also one of the best in the world. So where do we go from there? What's up at that point? What's the boundary? We call this the moving boundary. Typically, when we're talking about AI, it's whatever is coming next. Now, I think for me, this goes from the game playing and the expert systems, it goes to this broader term of intelligent systems. And this I like quite a lot, because what we're saying here is we have traditional AI, big data, lots of sensors, enormous data feeds coming together. What do we do with this? Well, we feed them into cognitive models to take decisions, smart decisions, based on the context, the circumstances, and our prior experience. This is profound for me, because this means we're creating systems that can acquire information, can learn, and can take decisions. Potentially, we're talking about autonomous decision-making systems, machines. Now, I'll give you a couple of quick examples. You might know that many modern military aircraft are almost completely driven by or piloted by machines. That the number of decisions per second to keep those planes in the air is greater than a human can conduct. So it's mostly the machines flying those planes. You may also realize, you've been following the news, that we have cars that are becoming autonomous. That in fact, the cars are becoming more and more autonomous with each of its individual components. The braking system, the steering system, the lights, the backing up, the cars can park themselves, and now we realize maybe they can drive themselves. And if you think about it carefully, many of the experts that have studied this believe that self-driving cars will do a better job than humans. Humans are terrible drivers. We're easily distracted. We're on the phone, we're watching stuff on the side of the road, we get distracted by the kids in the back seat. Cars that are self-driving with all the sensors don't have such distractions. So the expectation is that this, not only will it happen, but it will happen quickly. And so we're talking about intelligent systems for locomotion, for all manner of vehicles and mobility, for cars, for trains, for planes, for buses. And this is happening not in the far future. It's not science fiction. It's happening right now. So these are instances for me of autonomous systems, of intelligent systems that incorporate autonomous behavior. Now again, we have experts here on these subjects who can tell us a great deal about it. So now, somewhat playfully, I'm going to walk you through some concerns. Let me go a little bit further and then we'll take our break. We'll take a short break. Now, why do I show this picture? Well, because some people laugh saying, well, it's like us howling at the moon. What can we do? No matter how much yelling we do, we don't solve this problem. But there's another reason that I show this picture. Because this idea of the werewolf is important, partly because these problems are so big that for you guys, it might keep you awake at night. You're under a lot of pressure to deliver digital Kazakhstan initiatives. So this is maybe very powerful, but really it's about this. There's no silver bullet. Do you know this expression? In English, what we mean by this is we can't kill that werewolf with one shot. There's not any one thing that we can do that will solve this problem. So the phrase no silver bullet. So this is why, if you're going to remember something from my presentation, I'd like you to remember the scary beasts and the silver bullet. Now, I want to emphasize, this is a terrible picture, but I want to emphasize that we actually cannot solve this problem. I'm glad that the Deputy Prime Minister isn't here at the moment, because he doesn't want me to say this to you. But guys, we can't solve it. There's nothing that any one of you is going to do to solve it. But we can improve it. So the digital transformation is achieved through incremental improvements, random setbacks, and occasional breakthroughs. And that's really what we're looking at, moving forward in small steps and occasional big ones to get there. Each year we have a little bit more bandwidth in our organizations. Each year we have more devices that can accomplish some of these goals: better servers, better machines, better phones. Each year we have maybe better trained staff members or better tools on the market that we can utilize. So it's incremental. It's hard to see, but you get the idea. From where we are now, getting to a future state with improvements. But sometimes we take a bad decision. And I'll pause after this slide, but I'll tell you why this is a bad decision, and I'll tell you why it's actually terrible for two reasons. You probably recognize this famous keyboard layout. What do we call it? QWERTY. QWERTY. This is the English language one, of course. Why was this keyboard designed with this configuration of letters? There's a famous story. Was it done to help humans type? No, it was not. Please. Thank you. So you've arrived just in time for a story. I'm explaining why occasionally we make terrible decisions with technology, even with good intentions. So this keyboard was designed not to help humans type better, but to slow them down on purpose, because the keyboard was mechanical. The keys were striking a surface to transfer the image of the character. If you typed too fast, the keys would jam. So the guy that developed the keyboard put the keys that you use the most frequently under your weakest fingers on purpose to slow you down. We have been using this keyboard for, 100 years. We don't use a mechanical typewriter anymore, and yet we're still teaching people this configuration. This is a terrible interface to the machine. We should be able to do better. So that's one problem. We have a terrible design flaw, which we have inherited as a legacy. We should be teaching our children not to use a device that cripples them, but to use devices and interfaces that enable them. Now there's a second problem. For many years, when I was in America working with schools to improve the level of technology, to raise the capacity, many schools decided that computer literacy must begin with keyboarding. And they were sending 7-year-olds into the laboratories to use those keyboards. But why was this a problem? Because even when we were teaching children touch typing, we were starting at the ages of 11 or 12. We were sending in children to use a machine that they couldn't use and that was designed to slow them down, and we were defining that as computer literacy. You can see a good intention with a terrible outcome. We wasted a tremendous amount of resources with this keyboard. Now, actually, I'm going to pause here. I have a short break. We have tea and coffee across the hall. I've given you a brief orientation as to what we're doing, why we're doing it, what resources that we have at the university that we can align with Digital Kazakhstan. I've explained the upcoming seminar series, and then I have a couple more stories to tell you after the break about technological innovation, about why the internet is in fact in some ways a terrible tool for us, why it's partially broken, how we can try to fix it. And I'll speak briefly about authentication, and because of the great interest now on the part of the government, I'll talk a little bit about the fundamentals of blockchain. And then towards the end, I'll give you a preview of the upcoming sessions, and then we'll break for just discussion. So please, everyone, take the next 15 minutes, have a coffee or tea, and we'll reconvene back here. Thank you. Welcome back. I hope you have some energy, because I think in the first half we were too slow. And now the second half, I'm going to give you some work. I do want to emphasize 2 points. The schedule that I showed you was the draft. we will be sending to you a slightly updated version. For example, a couple of typographical errors, and also the schedule for the multimedia database engineering. You might notice it's on the Saturday before Naris. Many people cannot attend on this day, so our speaker has graciously agreed to move the presentation to another day. Now, I also want to tell you something important about this presentation today. It's the orientation. It's the beginning. It's conceptual, not very technical. Some of the future presentations will be much more technical. They will have a beginning, which is the idea, and then the middle, which is the implementation, and the applications, and then ideally we're connecting these ideas to your projects. So we're trying to align these topics with your works. And we're going to be doing this collectively, together, in the coming weeks. So if you have strong opinions about these subjects, about the topics, please bring them to our attention. And to the best of our ability, within this series, we can cover some of them. But some of them will be separate. Assessments, reflections, micro-trainings, these things all come later. What we're doing now is meant to be a high-level seminar series, awareness and scoping for the decision makers and managers of these projects. Okay? So just for clarity. Now, I'm going to tell a couple of stories. You might recall our beasts. You know this, the technology trends, the number of users, the number of machines, the number of devices, the core applications which have migrated from traditional delivery to these electronic deliveries, e-education, e-health, e-banking. But with all of these transformations, they come with vulnerabilities, because none of these systems are perfect. No piece of software is 100% correct. Why are we on Windows version 27? It's because the previous generations all had flaws, vulnerabilities, weaknesses. It's continual improvement. But it means that with every release, with every application, there are vulnerabilities. And because these vulnerabilities exist, there are exploits that take advantage of these vulnerabilities. And people attempt to divert money or services. If there's money at stake, of course, criminals will be interested. So this comes with some risk. These transformations come with risk. Especially when we talk about the introduction of electronic currencies, online payment systems, and now blockchain and cryptocurrencies. I've been studying these issues for a long time, and I'm still not sure I could tell you everything about blockchain and cryptocurrencies. Now, in the next few minutes, I'm going to talk about some of these vulnerabilities. I'm going to talk about the need for authentication, and then I have a brief review of the core principles of blockchain. So with your indulgence, we'll cover this material. And then at the very end, I'll talk about the upcoming sessions. Okay. Who's this guy? He's a famous bank robber. He's a criminal. He could have been. Al Pacino was like a gangsterish guy. This guy was more solo. He was a bank robber. And one of the reasons he's famous is because once this is a long time ago, they arrested him and they asked him, why do you rob banks? And of course he said, because that's where the money is. But actually, that's not what he said. And they interviewed him later. If anyone had asked me, I probably would have said it. That's what anybody would say. It couldn't be more obvious. But what did he really say? Go where the money is and go there often. That's more alarming to me. Because when you think about the internet and you think about online transactions, it's vulnerable. The internet's great, but it really wasn't designed for what we're trying to do. It was for messaging, not for transactional business. This phrase, if you are connected to the internet is connected to you. That's important, because it means if you're connected, you're vulnerable. The second part of this, the only way to be sure that you're safe is to disconnect. Do you know who said that? One of the world's leading researchers on computer security. Huh, that's kind of disappointing. We all want digitization. We think we can make things better, more efficient. But in fact, we make them potentially more risky. So the retrofitting of the internet to support this authentication, more security, and this term, non-repudiation of transactions. This is our collective struggle. Now, what does non-repudiation mean? It means if you undertake a transaction, you can't say later, hey, it wasn't me. So if you buy something on Amazon, if you make a withdrawal from the bank, the transaction stands. The transaction holds, because we know that somehow you initiated, offered and accepted, executed the transaction. So the internet again, and the applications that rely on internet connectivity, because we often get these, we use them interchangeably, this is a problem for us. We need to improve this situation. Now, this is a famous cartoon. 25 years ago, this was published in the New Yorker magazine. And what does it mean? It's basically saying that on the internet, no one knows who you are. Now, in this case, no one knows you're a dog. I use it because it's so famous. From the earliest days of the internet, people understood that when you're online, you could be anybody. For example, who's Genghis Khan 2015? I have no idea. A user ID online isn't necessarily connected to anyone. In fact, there's a whole lot of discussion in the United States right now concerning this idea of online IDs and how they correspond to people or not. Now, of more concern to us, more fundamentally, is how do we know that a student is actually taking a lesson online? Because remember, maybe we're trying to deliver some online education to remote places that don't have good books. So we're trying to deliver a good lesson. But how do I know I'm getting the right guy? How do I know that the person taking that quiz is the person, the right person, in the records? So we have issues. How do I know in a hospital how to connect the laboratory results to the right patient? If you get that wrong, there could be trouble. So for us to go forward, we have to get these things right. So authentication. How does anyone know? In the old days, in your neighborhood, people knew you. They knew your family. They knew you knew your family going back 7 generations. Your buddy knew their family going back generations. So there was some kind of confirmation. People knew where you came from. But as you move away from your town into the city, into the virtual cities, online, we lose that. So for example, why do we need government documents? Because that is some kind of attestation of your identity. It's a government-recognized birth certificate, driver's license, passport. But even then, maybe that's not good enough. Who has the authority to issue these documents? Who has the authority to confirm that the documents are real? Why do we even need something called apostillization? So that in another country, that same document can be checked against the issuing authority. So we now have levels and levels of attempts to authenticate people in the real world. So this is a non-trivial problem. Just to see who individuals are moving around in a physical setting, now imagine this online. So for us, we have to think about authentication as the verifiable association of an identity, Genghis Khan 2015, with an individual. Every one of your applications at some point is built on this premise that you can identify the users. Every transaction online typically begins with an ID and a password. But is this actually authentication? It doesn't prove a thing. It just proves that you know the ID and the password. And by the way, if you walk into any boss's office and you look on their screen, what do you find? Sticky notes with all of the IDs and passwords. Or the secretaries that know all of the IDs and passwords. So the person using the account isn't really the person whose account it is. So how do banks deal with this? They introduce extra levels of authentication. They introduce one-time PINs or your recent history of transactions. Or maybe code words. Or maybe they do fraud detection because they know your patterns of usage, coming back to the big data idea. We know what's normal, so therefore we know what's abnormal. And we can begin to call this out. Almost all of our applications, by the way, in data science and big data are about that issue. Recognizing what's normal, understanding the patterns in general and in particular, and then recognizing what is abnormal, so we know if it's irregular. Now, single-factor authentication is okay but not effective. Multi-factor is better. So as a brief lesson, 5 minutes, let's talk about multi-factor authentication. Something you have, something you know, and something that you are. Typically, multi-factor means at least 2 out of these 3. Most of us have seen this. Many of you are experimenting with how you will introduce multi-factor authentication into your digital Kazakhstan projects. Well, here's one quick example. That handsome guy on the right happens to be a former colleague of mine from New York University, now a very well-established professor in the US. He introduced an idea, was one of the early advocates for something called keystroke dynamics. The way you type is actually more unique than what you type. So if you type a passphrase, the duration of your keystrokes and the delays in between your keystrokes is measurable. So there is a profile. So it was an introduction of biometrics for authentication for someone using a computer. And it was transparent. This is a cool idea. Something you know and something that you are. If I know your password, I can't type it the same way. Now, of course, there are lots of problems with this. What if you have too much coffee? What if you came in from outside and it's a little bit chilly, maybe 40 below? Your hands don't work so well. So you could have problems if we use this. But it was a great idea. So if I were working with students, I would ask them all kinds of questions about how effective is this? Where can I use it? When can I use it? When does it break? Now, I'll walk through a quick example that might be relevant about authentication. And I'll use an example in the physical world because for many of us, it starts with physical premises that we need to secure. But many of these ideas can migrate online. Suppose you might recognize this place. Suppose we want to regulate access to our buildings. Everybody has a card. Why did I choose this card? I like it. And our partner was Carnegie Mellon, and I spent some years with Carnegie Mellon. It's a nice visual. But let's assume we all have one of these, something you have. And your ID card, as you move around, can be detected. Then, in the system, we know that you're one of our people. You're a student, a faculty member, a guest, but we have you in the system. We have information, including a picture. So another example of something that you are is once we detect your card, we pull up your record, we grab your picture, we have a camera that takes a picture, we compare the 2 pictures, or some numeric representation of those pictures. And we see if you're someone who should be here or not. This is actually a very straightforward thing. If you've worked with facial recognition, this isn't hard because we're not taking a picture and looking at a million pictures to compare. We're taking a picture to compare to one other picture. Okay, so maybe we're introducing some physical authentication. A card that you have and photo ID. Now, at a practical level, this is useful. I know if people are allowed to be in certain buildings at certain times, or for a certain exam, or for a certain lecture. You could apply this to any ministerial building, right? The people that are supposed to be there should be free to move around. The people that are not supposed to be there, we should bring them to the attention of security and implement our policies. Here's another example. I only use this as an example of our research. Gait tracking. It turns out that the way you walk is quite distinctive. more unique than fingerprints. One of our students last year did a project on something called gait tracking. Gait tracking. And we can take the geometry, your skeleton and the way it moves, and we can numerically represent this in a way that is unique, identifiable. Think about this. Sometimes you recognize people from far away by the way they move before you can see their faces. So probably intuitively you know a little bit about the gait tracking. However, here we've got a potential problem, because when would this work? When might it not work? How could I trick the system? This idea of obfuscation. If I'm using some recognition system, many people try to get around it. And we're living in a cold place in the middle of winter, long coats, boots, sometimes the girls in high heels, sometimes tennis shoes. There are things that could maybe throw off the algorithm, throw off the recognition. So we would need to know, when does this work and when does it break down? But still, it's another potential transparent factor that we could introduce. Of course, voice recognition, fairly identifiable. Someone in the system, we have a voice print, we might have the opportunity to control spaces or control and confirm identity by using vocal recognition. In any given situation, you have a lot of choices. You would have to choose which of these are most important, most relevant, most useful, most cost-effective for you. Now, the point I made was simply that authentication is a fundamental issue, and that we need to resolve this in the early stages of a project so that we understand what's real. But as part of confirming what's real, we have to think about transactional security. So we talk about authentication, we talk about transactions. What was the term I used earlier? Non-repudiation. When a transaction is made, I don't want to be able to, I don't want it changed in the past. So there's a lot of discussion then about this idea of blockchain and cryptocurrencies. So for just a couple of minutes, let's talk about these ideas. The reason I introduced this today is that the Deputy Prime Minister has emphasized the importance and has a lot of projects underway in each of your respective departments now, because they want to see some achievements in areas where it makes sense to implement the ideas. The dilemma is, it's not always appropriate, or maybe not all of the pieces are in place. So we need to recognize which areas give us early wins and which ones have dependencies that we don't control that might take longer. So this curse, interesting times, upheavals, these could be very upheavaling. An old cartoon, people don't trust the government, the legal system, the media, and so on. It's supposed to be funny. May you live in interesting times. Now, briefly, what do these have in common? They're all forms of currency. On the left, that's beads that American Indians used to trade for items of value. We have gold, silver, and so-called fiat currencies that are controlled by governments, issued by their authority, presumably with the backing of their economy and a central bank. Okay, fine. But we're moving from these to other forms of currency. For any currency, it's a medium of exchange, a store of value, a mechanism for payment. And we have open markets where the value of a dollar, a tenge, a euro can fluctuate by the hour, by the minute. But what happens when we move outside that structure? When we move away from gold, silver, or a dollar or a euro backed by central banks and the local economy, and we move to something separate from this. This is both the opportunity and the danger of a cryptocurrency. Now, I start with the cryptocurrency and I'll unwind it. This won't take very long. we've heard about these. We'll hear more about them. Why? Because there are many. I gave a talk 3 or 4 months ago to a group of regulators about cryptocurrencies and blockchain. When I gave that talk, there were 840 cryptocurrencies. Just in the intervening months, it's doubled. 1,541 cryptocurrencies and counting. And you can investigate these by visiting this site. The market capitalization of all of those cryptocurrencies is staggering. Okay? Why the hype? That image is supposed to be like an earthquake. It's a seismograph, right? Why the hype? Because it could be disruptive. The use of these currencies could change the approach. And in particular, the ability of governments to control currency and taxation and related transactions. So what are the characteristics? Just as a reminder, decentralized, unregulated, independent, direct transactions without the intermediation that would have come from banks previously, potentially limited supply, but what's it limited by? I don't know. I mean, there's a limit on the number of bitcoins. Does anyone know the maximum number that's supposed to exist? What's that? 21 million. 21 million. Why 21 million? Just because somebody said so. Could there be more? Sure. Who would say so? I don't know. Like, there could be an infinite number. But that would, of course, devalue that as a currency. You can see the potential problem. And there is evaluation through exchanges, but the exchanges are still suspicious because of potential manipulation. But the advantages, okay, rapid settlement, low overhead, again, being borderless allows things to happen faster. When I say impervious to counterfeiting, you can't double spend. There's a way to determine whether the same coin has been used twice. So there's a way to mathematically, scientifically confirm the transactions, the value, the exchange, and so on. And the potential down the road, which I'll talk about briefly, of embedded rules and self-fulfilling smart contracts. So bear with me for a minute, because I'm going to tell you a story. I'm going to tell you the story briefly because sometimes people don't know what we're talking about with blockchain. So how do I explain the fundamentals? How do we reaffirm the underlying ideas? So I use maybe something like this. What's hashing? Well, for those of you who studied computer scientist, you should be very happy right now because your prior learning becomes more relevant. Let's say we take a book, all the text inside that book, and I submit it to something called a hashing function, which for this purpose I represent with a grinder. Because once I grind this up, I can't put it back together. When I put the book through, the contents of the book, through the grinder, through the hash function, what I get out is a number, a string of hexadecimal digits, but short, not very long, fixed size. So from a long book, I get a very small number. So this is the concept. I have a hashing function, and input of any length book, ranging from a short story by Hemingway to something by Tolstoy. Let's say War and Peace. Both of those would generate one string, same size, okay? If I take that book and I run it through that hashing function 2 times, should I get 2 different numbers? No. I get the same number, which is what I try to show here. Okay, so far so good. If I take 2 different books, I should get 2 different numbers. I won't go into the math of this, but let's just say it's true. There's some small qualifications to this, but by and large, the odds of getting the same number would be infinitesimally small. Okay, so this is good. Maybe. How can I use this? I come back to my 2 books. I have 2 different numbers. What happened? What's the implication? If I run one book through the hash function, I run the second book through the hash function, I should get, if it's the same book, I should get the same number. If the number is different, what do we know? Not time, but one version of the book is different from the other. We know for a fact one version of the book is different from the other. And we know this very quickly. This hash function, it takes very little time. We run the book through, we get the number, we can compare the 2 numbers. It's a simple, like 1 computational cycle comparison, and we know that they're not the same book. Why is this interesting? A single character in a book or a pixel in an image will change the resulting output value. So I can take a lot of these documents. I can generate these hash numbers. I can save a lot of space, and I can save a lot of time. It's trivial to compare these sets of data to see if they're equal or to see if they've been changed. Why does this matter? Okay, now think about transactions. In the past, if you were an accountant, you had a central ledger. All of your accounts were in one place, right? A centralized ledger. This is Scrooge. Okay, centralized. We could have a distributed ledger, electronic. Timestamped transactions stored digitally across multiple places, distributed, replicatable, shareable, resilient, fault tolerant. What does it do for us? The blockchain is an implementation of this distributed ledger. It's a linked list of these records, a chain of blocks. It's like this. Now, what I mean is, all of these are individual transactions. Some sale, some contract, buying or selling grain, for example. Anything. You have a block of these, a set of them, together. You submit that block through a hashing algorithm. You generate that hash function. You're able to retain that number, so that block is preserved. And you have a series of these blocks that are linked together, such that if anyone ever changes an old record, it's detectable. And because you have multiple copies of this in multiple places, no one controls it independently. So, this ledger of transactions is not just centralized with one person, one place, easily changed, but multiple copies, multiple places, and if any one of these transactions is modified retroactively, it's detectable. This is actually kind of good, because it means we're able to maintain a historical record that's not readily altered. So the blockchain itself is self-validating, essentially, and nearly impossible to change. I have an asterisk there. Later in the seminar series, I'll talk about the details. So why do I have this picture? Because one of the first implementations of the blockchain in Kazakhstan is for grain contracts. And what's nice about that is that it's independent of any cryptocurrency. It's just the transactional records. So what did I say at the beginning? Some of these technologies are very well suited for certain kinds of problems, for early achievements, right? Early successes. Others have dependencies that we can't overcome and that they might take longer to implement because of it. So something like implementing a blockchain to help support and verify these transactions for grain seems like a reasonable starting point for this. I think it's a good idea. Now, so what's the deal? Why do we use it? It's effective. Is it the same as a cryptocurrency? No, it's not the same. Can I have a blockchain without cryptocurrency? Well, yes. We just gave the example of these transactional records of grain sales. Can I have a cryptocurrency without the blockchain? Maybe. But most of the ones I listed, out of that 1,541, virtually all of those are based on blockchain for their internal validation. So the idea of the blockchain helps detect the double spending, eliminating the counterfeiting, and allows us to, in a way, incorporate more than just transactions, but actually, in legal language, this concept of offer and acceptance. So contracts can become embedded in the blockchain. And this is where the future of blockchain is going, where the reason I use this picture is that they have more transactional records. In this case, in the blockchain, they're showing housing contracts, right? Deeds. Now, of course, for that to work, the original deeds have to be known and registered. There has to be a starting point. So this has some potential. What they're calling Bitcoin 2.0 is the idea of the platform. More than the money, it's the platform. Now, later in the series, we'll talk more about these ideas. But I wanted to mention briefly some of the issues related to cryptocurrency and blockchain because it's one of the hottest topics in your own working groups right now. Now, for regulators, there's a problem because faith and confidence, what happens if one of those 1,541 cryptocurrencies fails? What are the odds of some of them failing? Quite high. Will they all survive? No. If some of them fail, what's the cost of that failure? Are we willing to support, to live with the repercussions? So the issue of the cryptocurrencies is a big deal, but the potential of distributed ledgers and blockchain by itself is quite good. It could be over time that the regulatory framework is embedded in the blockchain implementation, such that the problems become more or less mutually resolved. Now, what this would require is vigilance, real vigilance, on the part of the government and the regulators, and making sure that the early pilot projects are well organized, well designed, efficiently implemented, so that the achievements are real. There are efficiencies. There's transparency, there's clarity, there's faster resolution, lower overhead costs. The example that was being given earlier by the Deputy Prime Minister talked about big efficiencies and improvements in utilization of resources and the cost of delivering those resources. So there should be big benefits to us. So we need to choose wisely. Now, I gave you several general topic areas, but I'm fast running out of time. So let me recap briefly and then give you a preview. I wanted to talk about why we're meeting. We're doing this at the request of the government. We're doing this to help support and facilitate the ambitions of Digital Kazakhstan. We're working together with Zerde and the broader community to move towards these objectives. We have several levels of engagement. One are these seminars. Another could be educational programs. Others, micro trainings. There could be project-based cooperation with our students and our faculty. But we would need to hear more from you to help shape these activities going forward. The seminars and the others, so that we can make the adjustments as we go. We'll send you a survey that asks for some feedback from you to help with that balancing. Now, today, it was not very technical. I told some stories. But in the upcoming sessions, they will become more technical. So let me tell you some stories. And I didn't show these slides to my colleagues, so I get to make things up, and then they get to untangle them later. But next week, we'll talk about big data and data mining. Dr. Sterling is here. He's a specialist. He's training, 30 to 50 kids a year in the data mining. The projects they're doing are phenomenal. So why do I include the abacus? We've got better computers than that, but for me, it's a symbol of computational power, okay? Big data. Now, from there, we'll go to machine learning and artificial intelligence. I like the picture. We don't build those robots. And I'll say a little bit about this, because behind me, there is an army of academics, of specialists that were hired to be specialists, experts in their field who have whole teams of people. Let me give you a flavor of that. In our robotics department, these are all courses that we offer. We're training specialists every year in these courses, in these subject areas: machine learning, brain-machine interfaces, HCI, HRI, robot perception, autonomous robots, and so on. We're doing it under the direction of this guy, the chair of the department. He runs groups in areas like smart industry. And by the way, on the right, we have faculty that come from the School of Science, the School of Engineering, the School of Business, the National Laboratory. They come from all over our university. We have a group on big data and machine learning. Again, fairly specific activities. You can see the terms. We have one on the healthcare and medical, because the impact on medicine will be enormous. Medical care in the future will be a far different creature than what we have today. Image processing, the guy on the left is our guy. The girl on the right is one of our former students. And she just finished her graduate degree in Germany. She did a project on threat recognition. So this guy isn't threatening her. Her work is threatening him, because she conducted this project that did threat recognition in images, looking for weapons. As an example, he'll give you better examples, but because I'm giving today's talk, I got to choose this one. Here we have Dr. Adnan, who does multimedia database engineering. I mentioned earlier, he's recently joining us from Middle East Technical University. And we're adjusting the timing of his talk, by the way, so we'll send the revision on this. This is a slight digression. I just like the idea, because where we're going is something phenomenal. You might recognize that guy too, but holy cow, biotech, genomics, personalized medicine. We could give another 2 hours just on the promise of this alone. Now, bioinformatics, we have Dr. Schonbach in the back, who's the chair of our Department of Biology. He doesn't use that bracelet, but I like it. It's a reminder to me that in the future, you'll all wear devices that collect data routinely, that communicate to your phone, that figure out whether you're okay or not. And if you're not okay, your phone will know before you do. And if you need help, it'll communicate before you can do it. So this approach to healthcare will transform the future. Now, what he's doing isn't just healthcare. It's much, much broader. Bioinformatics is an extremely rich and deep field. He'll tell us all about it. And then this computer science lab at our national lab, briefly, they do a lot of work, in particular in natural language processing and speech recognition. And they, again, have quite a big team of researchers. I keep saying it's more than just me. We have some tremendous resources available for these subject areas. They're doing a lot of work on, for example, the Kazakh language corpus, a dependency tree bank. What it means is they can recognize Kazakh. They've got a vocabulary that's very, very big and very conversationally correct. So the systems that people are using now with some of the companies, the chat bots for technical support, this work could vastly improve that kind of interaction with our citizens. Now, the last one I'll mention, we're pretty much done for the day, sensor networks and smart cities. We have 3 researchers, Dr. Mona Rizvi, Dr. Sain Saganbekov, and Mark again, who are specialists in this. Sain is here. These guys do work with sensors, sensor networks, the data collection. This is kind of the front end of the big data idea, but in a way that's applied to try to do a better job of managing cities. And what that means, they'll explain it in greater detail. But the application areas are vast. Now, having said all of this, if we had time, because I'm a storyteller, I would tell you another story. But we don't have time. So this is a preview for cybersecurity. Towards the end of our seminar series, I'll talk about the levels of cybersecurity, how even in that field, no silver bullet, defense in depth, improvements at every level, awareness, training, and so on. I'll give you a very, very full picture on this, but I'll save you. I won't do it today. We'll do this later in the cycle as we go forward. Now, I think I'm going to pause here and just mention, luck favors the prepared. We do better if we're ready for it. I make a lot of references to kids' movies because I have kids, so I mostly see kids' movies. Guys, we asked you here today to give you this introduction, to introduce ourselves, to introduce our leadership, to introduce our faculty, for us to meet some members of this team, to tell you what we're going to do going forward so that you can help us shape what we do going forward and maybe do some matchmaking. I hope it was useful. I hope to see you again next Saturday when we cover the topic of big data. Now, on this topic, if you have some questions about big data or some example areas that you would like us to try to reflect upon before that presentation, please bring them to our attention, okay? With that, I'm done for the day. We'll stay a bit longer for anyone who would like to have further conversation for questions and answers, but I'll close the formal session now. Thank you very much.